Hello colleagues, and welcome to Week 1, Unit 7 of SAP Cloud Platform Version Control with Git. In this unit, we will learn about local branches. This is a very foundational concept for Git. It's also a very commonly misunderstood concept because people tend to approach Git without Git experience, maybe thinking they already know what a branch is. But I can say from my personal experience, having worked with several different version control systems, what some version control systems call a branch is not necessarily what is meant in Git when you describe a branch. So this short lecture is worth not skipping or not fast forwarding or watching on double speed, because whether or not you get this topic right will determine your ability to understand more advanced concepts. So I want to start by giving you a pop quiz designed to test what you may already know about branches. So here's the question. How many branches are depicted in the below diagram? Keep this in mind. It is a trick question. So go ahead and answer it in your heads or write down what you think the answer is. Okay, got it? In Git, a branch is just a named pointer to a commit. So in the previous slide, there were no named pointers. So the correct answer here is 0. There were no named pointers to commits, so there are no branches. Okay, that quiz is mildly irritating, but I'm using it to make an important point that a branch is a pointer to a commit. Note that a branch is not a divergence in revision history. It's not where you have a split. You could have several branches in sequence, or you could have several branches pointing to the exact same commit. So in this picture, you have 2 branches. Now, a lot of people who are new to Git might think of this as a single branch because it's a straight line of commits. But there are 2 branch pointers, and that means 2 branches. By the way, this is a good time for me to describe the notation I like to use for drawing commits in a repository. First, when I use a gray or green or red circle, that represents a commit. Second, when the commit is pointing to another commit, that means it's pointing to the parent of the commit. So in this diagram, the commit pointed to by the branch master came after the commit pointed to by the branch feature. I also like to draw repositories from either bottom to top, or if there's not enough room, from left to right, depending on the available space. So in this case, the oldest commit is on the left, and the newest commit is on the right. If I draw from bottom to top, then the oldest commit is on the bottom, and the newest commit is on the right, on the top. These seem to be the 2 most common conventions I've found on the internet, and WebIDE Git history pane draws from bottom to top. So back to branches. In this picture, you have 2 branches. Earlier I said that these 2 branches are in sequence. That's an important concept, and it's a phrase I'm going to be using a lot in this course. When I say that 2 branch pointers are in sequence, it means that all the commits are in a straight line. There's no divergence in history. So even though you have 2 branches with no divergence in revision history, what would happen if you checked out this feature branch right here, and you made some changes, you saved them, you staged them, and you made a new commit? Then what would this diagram look like? Think about it. You checked out feature, you made a new commit. Well, it turns out that when you check out a branch and make a new commit, the branch pointer is moved to point to your new commit. So if you were to check out feature and make a new commit, then your repository would look like this. Now, these branch pointers are not in sequence anymore, right? You can tell that because the commit pointed to by feature is not a parent or a child of the commit pointed to by master, and vice versa. The commit pointed to by master is not a parent or a child of the commit pointed to by feature. I'm going to go back a slide and show you that again because it's such an important foundational concept if you're brand new to Git. If you check out feature here and make a new commit, then your repository is going to look like this. Okay? Now, let's see how you've been paying attention with another little quiz. How many branches are in this slide? That's right. The answer is 3. A lot of people brand new to Git, who hadn't seen this lecture perhaps, would say 2 because you only have 1 split in version history. But you know better. You know that a branch is just a name pointer to a version. So you know that there are 3 branches here. Now, you'll notice that this branch called master comes up a lot. That name master is very common. The name master is the most common convention for the main branch in Git. If you create a new empty repository, it's going to have 1 branch, and that branch is called master. And we saw earlier that when you clone a repository, you'll get a master branch in the cloned repository as well. But other than creating a branch with that name by default, master is just a name and a convention, and Git doesn't give the master branch any special treatment that it doesn't give other branches. If you wanted to, you could make a different branch, your main branch, if your team decided to do that, or you could just delete the master branch entirely. One more thing, one more convention issue with branches that's going to be important. Sometimes in Git discussions, people talk about the head. This is going to come up again in this course. The head is just shorthand for saying the currently checked out version. Sometimes you'll even see people refer to head squiggle 1, which means the parent of the head, or head squiggle 2, or maybe head squiggle squiggle, which means 2 back from the head, I guess the grandparent of the head. That's common Git terminology, so you should know it. Also, sometimes in error messages or discussions, you'll hear people talking about Git getting into a detached head state. And sometimes you'll see that you'll perform certain operations, and you'll see that in the message. A detached head state is what happens when the currently checked out version is not pointed to by any named branch. That can sometimes cause problems, and in WebIDE it isn't possible because even though WebIDE will let you check out any commit in your repository, it's going to force you to create a branch pointing to that commit. You should know what a detached head state is because the repositories you connect to might have this problem, and knowing what it means is usually enough to know how to fix it. So, now you know the simple but often misunderstood concept of a local branch in Git. In the next unit, we will have a brief description of tags, and then we're going to do a demo opening WebIDE to do a few experiments with tags and branches.